Hello sir, my name is Sheikh Samira. I'm from CSCG section. Today's my topic on data structures is quicksort algorithm. Quicksort is a type of sorting technique. Quicksort is a type of sorting technique which works on divide and conquer methods. This divide and conquer has three basic elements: divide, conquer, and combine. Divide. The principle of divide is to divide the list into two sublists. Here we divide the list into two sublists based on the pivot element. Conquer. The principle of conquer is to sort the two sublists. Here we arrange the two sublists in an ascending order. Quicksort is a type of algorithm which by default arranges the elements in an ascending order. Combine. The principle of combine is to combine the two sublists into a single list. Here all the divided sublists are converted into a single list by using the combine principle. How does the quicksort mechanism works? Quicksort operates by selecting a pivot element from the array and partitioning the other elements into two sub-arrays according to whether they are less than or greater than the pivot element. Here the pivot, we are selecting a pivot element. The pivot element may be the first element or last element or the second element. We need to know that the elements before the pivot element are lesser than the pivot elements. The elements after the pivot elements are greater than the pivot elements. The sub arrays are then sorted recursively. Here again, by using the pivot element, we divide the list into two sublists. Again, the process would be continued as divide, conquer, and combine. This can be done in placing, requiring a small amount of additional amount of memory to perform the sorting. By considering a pivot element which requires a small amount of memory, so we use an additional amount of memory in order to perform the quicksort. Algorithm steps. Algorithm steps for quicksort. Choosing a pivot element. Selecting an element from the array as the pivot element. The choice, as I told you, the choice of the pivot can vary. It may be the first element, it may be the first element, the last element, the median, or the random element from the array. Partitioning. Reorder the array so that all the elements with the values less than the pivot comes before it. The pivot elements comes, the values which are less than the pivot elements comes before it, while all the elements with the values greater than the pivot comes after it. After this partitioning, the pivot is in final position. After sorting all the elements, the pivot would be in its final position. Recursively applying. Same the procedure would be applied as choosing a pivot, partitioning, and again applying the same principles. Let us consider an example. Here an array of size 5 of size 6 and the elements are 25, 10, 30, 15, 20 and 28. Let us consider an array. Here I am considering the pivot element as the 25, which is known as the first element. Considering the pivot element as the first. As I consider the pivot element from the left, the comparison would be started from the right side. As we all know that the the elements which are present after the pivot elements would be greater. So pivot element would be less than the scanned element. So checking each and every element from the right side. 25 is greater than 28, which is true. If the statement is false, the both elements get swapped. 25 is greater than 28, which is true. 25 is greater than 20. As the statement is false, this 25 would swap with 20 element. So 25 is swapped with 20. After swapping, the array would be as like this: 20, 10, 30, 15, 25 and 28. Now we are comparing from the left side. As we are comparing from the left side, the pivot element would be greater than the scanned element. So 25 greater than 20, checking from the first element, 25 greater than 20, which is true. 25 greater than 10, which is true. 25 greater than 30. As this statement is false, this 25, this 25 would be swapped with this 30. As 25 is swapped with 30, the current array would be 20, 10, 25, 15, 30 and 28. As we all know that one pass would be completed when the array comparison is happened from right side and the array comparison is happened from left side. Both the comparison from right side and left side is completed, so one pass is completed. Now let us start the second pass. In the second pass, again we are going to compare from the right side. Again we are going to compare from the right side. As we are comparing from the right side, the pivot element would be less than the scanned element. So 25 is less than the 28, which is true. 25 is less than 30, which is true. 25 is less than 15, which is false. So 25 is swapped with 15. After swapping, the current array would be 20, 10, 15, 25, 30 and 28. Now we all can see that the elements present before the pivot elements, which is 25, are in the very less compared to the pivot element, and the elements present after the 25 pivot element are greater. So now the list is divided into two sublists, sublist 1 and the sublist 2. After dividing the two sublists, here the sublist 1 and here the sublist is 2. The sublist 1 contains 20, 10, 15 and the list 2 contains 30, 28. Considering the list 1, the pivot element is 20. If we compared from right side, pivot element would be less than the scanned element. 20 is less than 50, which the statement is false. Considering the list 2, pivot element is 30. 30 and 28. Considering the pivot element, considering the comparison from the right side, pivot element would be less than the scanned element. So 20, as 20 is less than 15, 20 is swapped with 15. After swapping, the array would be 15, 10 and 20. Pivot element is greater than scanned element as we are comparing from the left side. 20 is greater than 15, which is true. 20 is greater than 10, which is true. So this condition is satisfied. The list is 15, 10, 20. The elements present before the pivot elements are less and there are no elements present after the pivot element. So the list is divided into 15 and 10. Here we need to divide the sublist until the sublist contains only one element. Considering the pivot element as 15 and 10, we need to compare from the right side. Pivot element is less than the scanned value, so 15 less than 20, which is false. So 15 is swapped with 10 and 15. Again, if the list is divided into sublist, it contains only one element. So the two elements are already in the sorted order. Again, if we taken in the list 2, as we before seen that 30 is less than 28. So 30 is swapped with 28. 28 and 30. This again divided into sublist. It contains a single element. So no need to divide the list. The given list would be in the sorted order. After combining all these sublists, we get the array in the sorted list, which is 10, 15, 20, 25, 28 and 30. Now the array is in the sorted list. Like this, we'll sort the given list into the ascending order by using the quicksort by taking the pivot element. The code of the quicksort is mentioned. Here we need to learn the code of the quicksort. Thank you.